Good morning, everyone, and thank you for joining us this morning. The objective of this call is to provide an overview of additional analysis that was conducted on the performance of the resource sufficiency evaluation process for the CAISO balancing authority area during the extreme heat events last summer. This is Christina Osborne from ISO Stakeholder Affairs. I'll be facilitating the meeting, and here to present the analysis is Guillermo Bautista Alderete, who is the Director of Market Analysis and Forecasting, and Rahul Kalaskar, who is the Manager of Market Validation and Analysis. We do have a few other ISO subject matter experts who are available to respond to questions, including Brad Cooper, Danny Johnson, George Angelidis, and Brittany Dean. We will stop and take questions throughout the meeting, so at that time we will provide instructions on how to raise your hand to enter the queue. We please ask that you start by stating your name and affiliation. We are recording the meeting and will make the video file available on the Market Enhancements for Summer 2021 Readiness webpage. That is where you'll find the presentation that was posted yesterday afternoon. And as a reminder for the recording, please request permission from the ISO before reprinting or sharing any related transcriptions. So with that, I'll turn it over to Guillermo.
Thank you, Christina. Good morning, everybody. Thank you for this morning call. Just to give you some background, we have gone through a few iterations regarding the discussion of how the resource sufficiency test perform, what is the logic, the current construct that we have, not just for the CAISO, but also for the EIM entities. And even though we have gone through at least a couple of rounds on this, there seems to be still some open questions that we want to make sure they are fully addressed so that we can really move into the next phase. You may recall we have gone through the Summer Readiness Initiative. There was an incremental change for the resource sufficiency evaluation. There will be in the near future a more dedicated initiative related to the resource sufficiency test. And the idea of having this call this morning is really to provide more analysis and answer the still open questions that we have heard related specifically regarding the performance of the capacity bit test for the CAISO. This call is not intended to be a policy discussion, is not a debate whether this is the right way to do it or not. This is simply to go over the analysis of what actually happened on August 14, how the test performed, and why we have capacity at that time, how we account for the transfers. It's a factual, historical assessment of what really happened on the days of the heat wave. We were very targeted to focus on the August 14. We have some material for August 14 and some other material for August 15. We believe these are the most critical times and only the peak hours. We believe these are the most critical times where we can highlight how the test perform on the most stressful conditions. With that, I would like to cover what the agenda is going to be for this morning call. We are going to start with some basic overview of the capacity test specific to the CAISO, and then the remainder of the material is going to be used to build upon the explanation to be able to answer the three questions that we have heard from previous rounds. The first two are specifically related to how the EIM transfers are accounted for or not accounted for in the capacity test for the CAISO. And I can tell you that the EIM transfers are not included in the capacity test, not for the CAISO and not for the EIM entities. And the third question we have also heard a lot is, how can it be that during the emergency 3 situation that you have on August 14 and 15, you were still passing the test and there seems to be still capacity available to be able to pass the test. We are going to elaborate on all the information that we prepare for be able to answer these questions, and then at the end we can come back to these specific questions and summarize the answers. So with that in mind, Christina, let's move to the next slide, please. Very basic preamble. As you know, part of the EIM construct that we have is that we rely on a resource sufficiency evaluation. That evaluation takes place for the EIM entities and also for the CAISO. Specifically to the CAISO, we have two tests that are applied. One is the bit range capacity test, and the other one is the flexible ramp sufficiency test. Specifically for the CAISO, we don't have a balancing test. We are coming upfront from the day-ahead market solution, and that serves, generally speaking, as the basis for the balancing, because we come out of the day-ahead already trying to meet our supply with demand. And in this sense, the focus has been quite a lot in the bit range capacity test. Next slide, Christina. What are the rules and processes we have around the capacity test specific to the CAISO? We still have the 3 rounds that depends on the timing when you are running the test. We have the standard time frames, 75, 55, and 40 minutes in advance of the trading hour. And the test for the bit range is performed in both the under and over direction, and that is done on a 15-minute basis. The first 2 tests that are for the time frame of 75 and 55 before the hour are advisory in nature, simply because there is a third opportunity that is at the T-40, in which if there is a time window there for operators to actively cure the infeasibility, what really matters is the outcome of the T-40. For EIM entities, I think there is indeed an active window in which an operator or an EIM entity can try to take actions to cure a potential failure between T75 and T55 towards the T40. The last result, the binding result of the test, is the one relying on the T-40. For the CAISO, even though we have these 3 rounds similar to the EIM entities, we really don't take any action between the T55 and 75 towards the T40. And the bits are what we have, and the operators just run the real-time market. So there is no explicit active action for us to try to cure any infeasibility or failure in preparation for the T-40. One consequence of failing the capacity test is that by default, we're going to be failing the flex ramp sufficiency test in the corresponding direction. That is just a default outcome of failing the capacity test. Next slide, Christina. Now, what type of information do we use to run the capacity test specific to the CAISO? Naturally, we need to have the reference of the demand side. For that, we use the 15-minute CAISO forecast, the load forecast. On the other end, we are going to have different components that are going to make up the supply side. One consideration that we have is the imports and exports. Now, specific to the CAISO, we have, generally speaking, 2 types of imports and exports. And I'm referring specifically to the intertype transactions applicable to the CAISO market. I'm not referring to the EIM transfers. For those intertype transactions, we can have at least hourly resources, 15-minute resources, and there used to be these one-time changing resources. Effectively, the hourly resources can only clear in HASP, and the schedules are achieved from the solution of the HASP market. After that, in every corresponding SMM market, they are fixed. Then we also have what we call the 15-minute market, and that could be resources, and that could be imports or exports. And they are, by its name, quite flexible because they can move on 15-minute basis. I would say that over 98% of the intertype transactions that we historically see in the market are going to be hourly transactions. Very few imports and exports are going to come on 15-minute basis. Therefore, the type of input we use regarding the imports and exports recognizes these 2 types of resources. If it is an hourly intertype, it's going to be categorized in what we call the net schedule interchange. That is no more than the summation of the imports minus the summation of the exports. And these are somehow considered fixed as given, because when we are running the last test, the T minus 40, they cannot really move, and they are just taken as a fixed value. On the other end, we are going to have the few 15-minute imports and exports that are going to be considered for the bit range, because they may potentially give us a bit range, because these bits, again, are on 15-minute basis. And the last piece that typically gets quite easily confused is about the imports and exports for EIM transfers. They are not an input to the capacity test. And even if they are imports or exports, they, again, are not part of the capacity test. And we are going to elaborate more on that through the material. Furthermore, we also have the resource bits. We account for all the bits that are coming for all the internal supply of the resources. Because the capacity test has to determine the available bit range, we also need to know the schedules that were awarded for all the upward and shared services if we are talking about in the upward direction. Because that is going to be capacity that is going to be set aside or not accounted for in the bit range, because it's already locked for providing AES. We also have to take into account the rates and re-rates for Pmax and Pmin of resources, because that capacity has effectively not been made available to the market. And one more time, the EIM transfers, again, are not included in the capacity test. And there is another component that we develop over time, and that is to account for potential intertype deviations. This effectively comes as a measurement of historical intertype deviation and makes up an incremental requirement to the test. Cristina, next slide, please. Now, with all these inputs and preamble, what is this bit range capacity test? There are different ways you can portray what a capacity test is, and I tried this characterization to see if it is simple enough to be intuitive. And the capacity test is no more than an assessment that we do to ensure that we have enough bit for the supply side in order to meet our demand side. On the left-hand side, the bit range capacity, you can see this as the equivalent of supply. On the right-hand side, we can see this the equivalent to the demand side. So we need to have sufficient supply to meet our demand. And if we meet that condition, effectively, the test is going to be considered to be passed. And we are going to be elaborating into the different components and how we came up to this high level. And the bit range, the bit capacity, the bit range, is no more than the total summation for all resources that are able to give us that supply. Before going into the details of this test, let's see if we have any questions at this point, Cristina.
Sure. So if you have a question, you can press #2 to raise your hand, and the event producer will open up your phone line. Just a reminder to state your name and affiliation first. Michelle, let me know if anybody enters the queue.
We do have a couple of folks in queue. Caller, your line is unmuted. You may ask your question.
Hi, Guillermo. Dan Williams from Customized Energy Solutions. I just want to check my understanding on something on slide 4. You talk about that the CAISO doesn't take any specific actions to cure for between the T75 and T-40 tests. But is it true that any operator actions that happen during that time could impact the passing of the test? And I'm thinking about things like exceptional dispatch, out-of-market purchases, maybe dispatching RDRR, arming load, and in the opposite direction, potentially doing any incremental load bias, that any of those may then impact the ultimate results of the binding test?
Yeah, hi, Dan, this is a great question. If you don't mind, I would like to put this at the very end, because I think at the very end of the deck, we have some material that goes into the operator actions. And I think I would like to first give the context, and then we can come back to your question and see if that answers your question.
Okay, sounds great. Thanks.
All right, we moving to the next question in queue. Caller, your line is unmuted. You may ask your question.
Hi, Guillermo. It's Lindsay Schleckway from Pacific Corp. I was wondering, could you go to the next slide? Yes. So my question is on the FMM schedules for upward ancillary services. So are you saying that ancillary services are included as part of the capacity that would contribute towards passing the capacity test?
No, it's actually the other way around, Kelsey. And we're going to expand on this in the subsequent slides. But the story is that we need to know how much capacity we have to subtract from the bit range that is associated with the upward ancillary services, because that is capacity that we cannot count in the bit range.
Oh, okay. Okay. All right. Well, thank you very much.
You're welcome.
Any other questions, Michelle?
There are currently no additional questions in queue.
Okay. We're on slide 7. Is that correct? There you go.
This one. Okay. And I may take some time on this because I think this is the most critical piece to ensure that we can have a educated discussion about the implications of the capacity test. Let me give you the background that in previous rounds of the CAISO explaining how the resource sufficiency evaluation works and what happened on the heat wave events and so on, we came with a general perspective of the bit range capacity test. And if you see, for instance, material in the BPM or previous material that we have elaborated on the resource capacity test, you may find that we refer to base schedules and FMM schedules and so on. And when you look at this through the glance of an EIM entity, it's quite intuitive to have that type of discussion because there are base schedules. They serve as a natural reference. A reference is always going to be relative to something else. And I think, for the sake of trying to show you in the past that the capacity test is basically the same applied to EIM entities and the ISO, we may have created an opportunity for some confusion about how the capacity test works for the CAISO. And that confusion may be related to what reference you use when you don't have a base schedule. So I will try to untangle that perception and make sure that it's very clear when we are talking about the capacity test, what we really mean. The math is beautiful on one end because it works out very well. And what I can tell you is that when we are talking about the capacity test, again, the notion in the previous slide is we need to have enough supply in order to meet all our demand. That is the genesis of having the capacity test. How we characterize that, how we work the math to go through the test may take more than one way to do it, and effectively you end up in the same place. Generally speaking, we can have two approaches. The incremental-based approach is what we have historically explained in previous rounds that relies on a notion of the base schedules have reference FMM schedules to calculate a relative bit range. On the left-hand side, we can start with a very simple approach, and that is a total gross-based approach. In this case, all what we are saying is I need to have my total bit range to be greater than my total requirement. The total bit range is supply, the total requirement is the demand side. How can we characterize that in the simplest term? If you look at on the left-hand side, we have Gmax. That is just the total bit range that is no more than the summation of all the upper limits for all the bits that we have for that interval. If we have total supply making up of, 50,000 megawatts of bits, that would be that value. We are just saying, what is my total bit range? And that has to be greater than my load forecast. If I have a load forecast of 49,000 megawatts and my total supply is 51,000, I know I can pass the test because I have more supply than demand. Now, the component that is on the right-hand side of this section, that is the load forecast minus the NSI. The NSI, again, is the summation of the total imports and total exports. If we are talking about, let's say, we have only hourly interties, the net schedule interchange for the sake of the T minus 40 is a fixed value. It's a fixed value because we are not reoptimizing that in the 15-minute market. It's a value that we already know by the time we are running into the test. And you can put that NSI as a subtractor to the load forecast to reduce effectively your load forecast. Let's say you have 50,000 megawatts of load forecast and you have 10,000 megawatts of net schedule interchange. Effectively, this is given supply that you know is already fixed and given. Effectively, your requirement is going to be 50,000 minus 10,000, that is 40,000 megawatts. The total bit range from all the bits and supply that you have on your system, in this case, has to be at least 40,000 megawatts to be able to pass the test. You can put it the other way around. You can put the NSI component that is being subtracted to the load forecast, move it to the right-hand side. And in that case, it would be Gmax plus NSI has to be greater than my load forecast. All what we're saying is my total supply, that is the bit range defined by the bits of resources, plus the fixed given NSI of 10,000 megawatts, has to be altogether greater than my total load forecast, that is 50,000 megawatts. So either way, it's just a way how you can portray the estimation. At the end of the day, this equation has to hold. My total supply has to be greater than my total requirement or demand in this case. In this context, we are talking about the total capacity. When you refer to a resource that has a Pmin, a Pmax, and you are just taking up the maximum value of the bit, it's a gross calculation. It's a total calculation. You don't care where that resource is right now operating, whether it has a self-schedule, a base schedule. You are just taking the total capacity that is available in the system. That is quite slightly different if we move to the right-hand side. And the right-hand side is a calculation that we can work out in the same way, but it's based on the incremental approach. In the incremental approach, we need to have a reference. When we are in the context of a EIM entity, that reference is quite obvious, and that is the base schedule. If you have a base schedule of 100 megawatts and then you put an incremental bit on top of that for 20 megawatts, total capacity is 120. You know base is 100, you have incremental bit range to be just the difference, in this case 20 megawatts. So we can really take this other approach because there is a natural, intuitive reference point for an incremental calculation. In that case, what we are dealing with is a test that is based on making sure that the incremental bit range is going to be greater than my imbalance requirement. What is my imbalance requirement? The demand that I have to meet on top of my reference point, whatever that reference point is going to be. And that is what the first equation stands for. If we unpack that equation, the delta generation is no more than the incremental bit range. And that is going to be the difference between my Pmax of the resource minus the reference point I'm taking. Again, for EIM entities, that reference point can be the base schedule. For CAISO, the natural reference could be the most recent available FMM solution, and we call this G start. So the difference, G max minus G start, is again just the incremental bit range. If you have a resource that is with a Pmax of 100 megawatts and is currently dispatching the most recent solution of FMM to 80 megawatts, or the base schedule is 80 megawatts, the incremental bit range is going to be 100 minus 80. That means that resource has 20 megawatts of incremental bit range, and that is relative only to your reference point, the 80 megawatts of FMM schedules or base schedules. And we can do the same on the right-hand side. my incremental requirement is going to be the difference between a point minus the FMM solution. And if you focus on the second component, that would be the second bracket on the right-hand side. That is load forecast minus the NSI schedule. And these are stats. Basically, is the FMM solution that is available by the time we run the test T-40. If you look at this equation on the right-hand side, that is G greater than load forecast minus NSI, you know that load forecast minus NSI is no more than G star. And that is the equation that you derive in the third row. This second component, LF minus NSI star, is equivalent to, say, my G star. And if you compare these two terms, now you have incremental bit range has to be greater than my load requirement minus my G stars. These G stars are highlighted in red because you can see the beauty of the math here. They are exactly the same on each side of the equation. You can naturally cancel them out, and they are with no effect into the final calculation. With that, what you end up with is this equation of Gmax has to be greater than my load requirement. What is that? It is exactly the same requirement that we have to impose when we do the capacity test on a gross approach, on the total approach. And that is the relationship you have between the left-hand side and the right-hand side. Why I'm trying to cover all this? Because, again, in previous discussions, we focus on the incremental base calculation, and that may have created some confusion to indicate, oh, you are taking actually your reference of the FMM schedule. But the FMM schedule depends on all the conditions you have in the system, including EIM transfers. Therefore, the EIM transfers are impacting your test. No, it's not. When you do the math and you see that the G star is on both sides of the equation, that effect is in both sides, and therefore it cancels out. This is the simplest way to characterize and tell you that even if you take an incremental approach to explain the capacity test results, and you rely on that base schedules or FMM solution, it doesn't mean that the EIM transfers are effectively included in the capacity test, because its effect cancels naturally on each side of the equation. What you are really doing is just a different way, more intuitive way to characterize what the capacity test is. And we go back to the basics. What is the capacity test? You need to have enough bit range to at least meet your total load requirement. And that is the genesis of the test. Whether you do it in this gross base calculation on the left or the right base calculation is the same. You achieve the same numerical outcome, and therefore you achieve the same outcome for the test. Pass or fail is going to be the same using one way or the other. And I think this is important to explain because, again, I want to make sure there is no misperception that by using this explanation of the incremental approach, one may think that the EIM transfers are influencing the result of the test, because that is not the case. And before taking questions, let me go through a very simple numerical example. Christina, next slide, please. Here you have, let's take the simplest scenario we can have. Let's say we have a set of resources that make up a total bit supply of 100 megawatts, and that my most current solution by the time I'm running the test at T-40 is setting that resource to be dispatched at 95 megawatts. We also have NSI, hourly intertie transactions, imports and exports coming through our interties. They do not include EIM transfers, and they amount to 50 megawatts. And then we have a load forecast of 147 megawatts. If we go to the gross calculation on the left-hand side, we are saying my total bit range has to be greater than my total requirement. What is my bit range? 100 megawatts. That is the total bidding capacity that I have. What is my total requirement? Is my load forecast 147, minus the 50 megawatts of net scale interchange that I already have as given because it was clear in the hourly process. They are just fixed injections into our system for the 15-minute market. With that math, you are going to end up that the test is going to tell you, do you have 100 megawatts of bit supply? Yes, in order to meet at least 97 megawatts of total requirement. Yes, the test is going to be passed. We have 100 megawatts in order to meet 97. You can play it in a slightly different fashion. You can say, if you pass the NSI component to the left-hand side, you can say that you have 100 megawatts of bit range plus 50 megawatts of fixed scale interchange has to be greater than 147 megawatts. In that case, the test is going to be 150 megawatts of total bit range has to be greater than 147 megawatts. Yes, the test is going to pass. So you can play with the components in any fashion. If we look at the illustration that you have on the top, the gross assessment is doing a comparison of the bit range versus the requirement all together, the blue plus the green together. It's just the absolute total comparison. When we move now into the incremental assessment, we are taking a reference. That reference point is going to be my G start. You name it, base scales for the IAM entities, FMM scales for the Kaizen. And we are saying Gmax minus my current solution at 95 has to be greater than my incremental imbalance requirement. How much is that? And you do the math. 147 for load forecast, minus 50 of the NSI, minus 95 of my generation schedules. The math at the end is going to play in such a way that you have effectively an incremental bit range of 5 megawatts, 100 of total capacity minus 95 of the solution. That gives you incremental 5 megawatts. And that has to be greater than the imbalance requirement. That is an incremental requirement. That is 147 minus 50 minus 95. And that is going to give you basically 2 megawatts. The outcome of the test is going to be the same. It's a relative comparison of the supply bit range against a relative imbalance requirement. Do I have enough incremental bit range to meet my incremental requirement? Yes, I have 5 megawatts of bit range, and that is enough to meet my 2 megawatts of imbalance requirement. Everything is relative. Everything is incremental. And here is the point I want to take home. We were saying that, yes, in this incremental assessment, we are relying on a reference point. That reference point is the 95 megawatts. That is my FMM solution. This 95 megawatts is in both sides of the equation. It effectively cancels out. You can just cross this 95 in red, and what you end up is effectively with a gross calculation. Therefore, taking a reference, relative reference to do an incremental test doesn't change the equation, doesn't change the outcome of the results. It just makes the results more intuitive to understand. But strictly speaking, it's not even needed. And again, all this incremental discussion is because naturally it's quite intuitive when you're talking about in the context of the EIM, because that reference point naturally is the base scale. Christina, let me pause here and see if we have any questions.
Sure. So again, if you have a question, press #2.
We do have a question on the line. Caller, your line is unmuted. You may ask your question.
Hi, good morning, Guillermo. It's Jeff Spires with PowerX. Thank you very much for the thorough explanation with this. I think the explanation and the numerical example are very helpful, and I agree with you in terms of the fact that the incremental calculation is the same outcome as the gross calculation. And I also just wanted to say I appreciate the further research into how the EIM transfers do or don't play a role, and the confirmation that they don't play a role in the capacity test. I think the explanation you gave makes sense to me on that front as well. I do think there is a related issue in the flex test that we've talked about in the past related to the role of EIM transfers in determining the starting point of a resource in the current hour when you're measuring their flex capability going into the next hour, but I recognize that's a different issue, and so we don't need to get into that right now. It's just another area that I think warrants further discussion at a later time. But with respect to the capacity test and the example you just walked through, although the calculation is the same, I do think there is another consideration as far as the gross versus incremental, and that is, as you mentioned before, the gross assessment is just much more intuitive, and particularly if you're, in this example, you're saying, okay, I've got a load forecast of 147 megawatts. I need to make sure that my internal resources plus my import and export transactions are at least equal to 147. And I think that is intuitive and it's clear, and that's in contrast to the incremental assessment, whereas you're showing in the example, the requirement is 2 megawatts. And that requirement is really hard to trace back to the details of the example without having all of those pieces and doing that math. When you just see a requirement of 2, it doesn't really, it's not easy to interpret. And I think that we'll probably see in later slides that the imbalance requirement during the heat wave for the CAISO BA was, sometimes it was a positive value, sometimes it was a negative value, but because it's that relative calculation, it's not easy to look at that number and be able to clearly understand what it means. And so I guess the consideration I think that we should include as part of this is, does that make it harder to identify errors? Because, you know, of course there were some errors that were discovered after looking back at the capacity test, but would it have been easier to identify those earlier if the test values were more clear? You know, if you had a 45,000 megawatt load, the requirement was 45,000, the supply was 46,000, and it's pretty clear that that lines up with expectations and is comparable to the operational reality. Whereas if you have that relative calculation, I think it's harder to see what's going on. So that was just one thing I wanted to raise. I think there's kind of a intuitive benefit of having a gross assessment that could be useful in ensuring the test is accurate going forward. I just wanted to get your thoughts on that.
Yeah, and this is very interesting because to this discussion, what I can tell you is that we have indeed implemented in the actual calculation the gross assessment. The incremental is again all because of this discussion about having a base scale reference, but indeed the actual calculation is at the gross assessment. Now, one of the complications we have gone through by the time we wanted to put this material together, for instance, is that, yes, intuition is working great when you have the gross assessment. When you want to boil down specifically as to where the capacity was really available when you are in these stress-type conditions, the gross perspective is harder to make it work because all what you know is that, well, my load was 49,000. Yeah, and I have 49,500 of supply total, so I passed the test. It's harder to pinpoint as to, yeah, where are you really thinking that the incremental capacity that is making the test to pass. So I hear you, and I have gone through that struggle because I think the gross naturally makes sense to explain what we are trying to achieve here. There is, in some cases, some benefits of having the incremental because at least allows you to track at the resource level what capacity may be available. So I would say that we actually rely on both to be able to make more sense of what's really happened, and that is really how we are able to put all this material together.
Okay, thanks, Guillermo. I appreciate that. I just wanted to raise it because I recognize the one issue about whether or not EIM transfers are included or not was an area that questions have been raised, and getting confirmation about that treatment was important. So I really appreciate that. But I just wanted to sort of suggest there are other benefits of having that more intuitive calculation, and so it's worthy of considering that, I think, here moving forward into the stakeholder initiative.
Yeah, thank you. Yeah, and just to check, I'm understanding your concept correctly. Are you coming in the context of what information EIM entities have at hand to know whether they pass or fail the test?
I think that's certainly part of it. I think, as a participant in the EIM, if you're looking at your requirements and your capacity test is basically a comparison of your supply versus your obligations, I think that's intuitive and consistent with how most people would be thinking about meeting their obligations for their BAs or for their systems. So I think there's a natural benefit there in terms of participating and being part of the resource sufficiency test. But then the other benefit that I see from it is making sure that the test is accurate, which just leads me to question whether some of the errors that were eventually discovered would have been noticed earlier if the requirements were more intuitive. Because, as we'll see in a couple pages, the requirement was sometimes a negative number, as an example. So, it doesn't really lead you to make much sense of that, or to immediately say, oh, there might be an issue here, we should look at it. Whereas if it was on a gross level, it's a lot more likely that you would see if either the requirement or the supply wasn't consistent with reality.
Yeah. Okay. Yeah. I think that's a very good point, Jeff, and I think we can take that point for further in the discussion of the enhancements.
Thank you.
All right. We do have an additional question in queue. Caller, your line is unmuted. You may ask your question.
Guillermo, good morning. It's Mark Simons with the Bonneville Power Administration. Can you hear me?
Yes, we can hear you.
Oh, perfect. I just wanted to ask a question. Really appreciate this analysis and the material here. Thank you for taking the time to go through it. On the NSI calculation and the use, I think you were referring to the use of the FMM as, a base schedule. And you get into this, I think, later in the presentation more, but wanted to understand your perspective as to how changes in the NSI as a result of, imports that are expected in future intervals might actually cause a unit to be dispatched down or into an offline position, and whether you think that plays in here. You talk a little bit later, I think, about the MSG units, for example.
Yeah, thank you for the question. I think this is really the genesis of the comparison I'm trying to put in perspective here, that for the sake of the capacity test, that is simply a relative perspective. When we're talking about the NSI here, this specific component is the piece that is already fixed, is not subject to change when we are in the last test at T-40. And that is because that is comprised of the hourly intertie schedules, the imports and the exports. And when we come into the FMM market, into the T-40 test, that capacity is already what we know is assigned to the hourly process, and we know that it's going to show up. Well, the expectation that they will follow through and they are going to deliver that capacity. And because that capacity is not optimizable or is not configurable in the 15-minute market, that is considered as given. It's just basically a fixed capacity that is already considered in the system and as part of the balancing equation. Now, there may be some cases in which there may be some imports, exports not delivering to what they are expected to do. And we ran into an initiative in the past about the intertime deviations. I haven't put this in the illustration here, but there is indeed an incremental requirement that we put on top of the load requirement to account in some fashion for the historical intertime deviation that the system has observed. And that is effectively going to increase the requirements to hedge for that deviation that historically has happened. So in that sense, whether the import deliver or not the schedule, the market at work, to some extent, is already included and accounted for in this incremental adjustment that we do for the requirement.
Actually, Guillermo, I appreciate that the interchange uncertainty is included in the requirement, and thank you for adding that. But my question was really more about when you do count on that import, for example, coming in, it will cause or it will free up more GMAX on this particular slide example. And that will also be, I think it's also true, correct, for future intervals in terms of, advisory dispatches, not just the binding dispatches. So if you could confirm that, that would be helpful. Because then the point then is that it might put some GMAX in a place where it can't respond within the hour. That doesn't implicate the either gross or incremental assessment. It just implicates how resources are counted.
Yeah, I'm not following the question. Christina, can you go back one slide, please? Yeah, and if you look at the gross, for instance, I think that is going to really be the way to see this in a holistic way, because you're indicating that, well, this NSI may change how this capacity of GMAX can be available or not. Well, this NSI is already given. What we are saying is that given this equation of the total requirement, the load forecast plus minus the NSI that we have, this GMAX is regardless where these resources were dispatched to balance with this NSI. We know that this NSI is here, and we know that this resource can make available up to the Pmax to be able to meet this imbalance. So there is no component of the dispatch on only one side here that can tell you that because I cleared this much NSI, now I have less Gmax here. The Gmax is still there. You still have a resource with a Pmax of, let's say, 100 megawatts. Regardless of whether you clear an NSI of 10, 20, or 90, that capacity is still there. And it's going to be utilized to balance your total requirement. And this is really the piece I'm trying to make sure that this is well understood, that this is independent of where your resources are dispatched, because all what you're saying is, given the requirement that I have, do I have enough capacity to meet that requirement? The NSI was already locked and secure 70 minutes before the hour, and these are given. They are fixed, and they are not displacing internal generation for this T-40. That capacity is still here.
Maybe I'm not being clear here, but my understanding was that capacity could, it would still be there from, bid range capacity, but it may not be attainable within the hour given either ramping or temporal constraints.
Okay, that is something completely unrelated to the NSI discussion. This is a construct that we have about the capacity test, which we are assessing whether you have enough range or not. And yes, there has been some discussion. I think that would be a meaningful discussion in the subsequent policy initiative to see if there is any consideration for the temporal constraints for the ramp accessibility of the resources. But I would like to untangle the discussion. That has nothing to do with the NSI. That is just how you account for the bit range, and at this point, we do not account for any intertemporal constraint.
So, future advisory net interchange do or do not impact the amount of Gmax that's available?
It does not. You have your capacity available simply based on what the bit is, what effective capacity is available once you subtract the rates and ASR works, but it's independent of what the current solution is and what the advisory feature solution is. And that is the beauty of having this growth-based calculation that highlights exactly how the math works.
Appreciate the feedback. Thanks, Bruno.
Thank you. Cristina, do we have any other question?
I don't think so, but I'll check with Michelle. Michelle, anybody else in the queue?
There are no additional questions currently in queue.
Okay, thank you.
Okay, yeah. I think I already covered this. Why we have spent a good deal of time in this presentation talking about the growth versus incremental. And I think the point should be obvious at this stage of the discussion that the incremental naturally is in there because the construct of the EIM is having this relative base scale point. Naturally, we extrapolated the idea just to highlight the fact that there is no big difference between the CAISO test versus the EIM test, and they are effectively the same calculation. That all considered, I think we can start going into the specifics of what we have analyzed further related to the August 14 event. The last piece, because I think we haven't covered that, and I think Kelsey had a question earlier today, is related to the input that we described earlier today. We have the total Pmax of the resource, the total bitmax. And if that resource is carrying some AS capacity, you name it, regulation, spinning, non-spin, in the upward direction, that capacity is not utilized, is not accounted for in the bit range just because it's not available for energy. It's already secure and set aside for providing AS. Similarly, if we have resources with some specific bit rates in the case of the upward direction, that bit rate effectively is going to reduce the capacity available. When you take these chunks of capacity away from the P max or B max of the resource, what you end up is what we call the upper economic limit. That is the upper value that is going to tell you how far we can go into the estimation of the bit range capacity test for a given resource. I avoided here to put a reference point of basic schedule, FMN schedule, just to give you the construct from above how these resources are bounded to account for the capacity that is not really available for the test. And there was an early question regarding the temporal constraints. Yes, the capacity range is no more than a capacity test. We are looking for counting the megawatts, whether they are there or not. That is not exactly the same as to say whether we can access that megawatt quick enough, like in the flex sufficiency test. If we start talking about the ramp capability and so on, we are really evolving into discussing what is a flexible ramp sufficiency test. And another component here is that, in general, the capacity test doesn't account for intertemporal constraints. It's not just the ramp rate, it's also the startup time, the time that you may need to come online, right? As long as the resource has a bit for that out, we can consider that the resource can get online and we can get access to the capacity. And I think it's a point for further discussion when we go into the policy initiative. if that is still a reasonable consideration or whether there needs to be other consideration of the bit range capacity test. I indicated at the beginning, what we are trying to come with in this presentation is not whether to assess if the current construct is the most ideal and the best construct that we have, whether we should keep it or change it. This is not a policy discussion whether we should or should not. The whole point of this discussion is to give you the factual information of how it's currently working and how that play and perform for the summer event. Next slide, please. Now, the remainder of the material is really a series of metrics and analysis that we have done. Interesting enough, much of that is based on the incremental approach because that is really the numbers that are easily manageable to put together. I think we can translate everything into a gross calculation, and you may see later on that once you translate everything into a gross calculation, when you're trying to look for these scarce megawatts at the tight hour, it's not very intuitive or straight to realize where these megawatts are. So that is one of the motivations. We still have to keep this analysis on an incremental basis. And again, you know that the outcome at the end of the day is the same. In this one, this trend was already discussed in the previous round of the resource efficiency workshop. And it tells you, it highlights the relative comparison between the imbalance requirement, that is an incremental requirement, versus the incremental capacity available. Naturally, you can see that as the day reaches the peak time, the bit range capacity becomes limited, and that is naturally when it becomes very, very small. This is based on the very original market solution as it was on production during the August 14, August 15 days. And the concept is the same, right? I need to have enough available capacity to meet my imbalance requirement. That means my line in black has to be greater than any bin in this portion to indicate that we failed the test. Or the other way around, the available capacity in bars is always higher than the imbalance requirement, and therefore we pass the test in every single interval. And that is really what raised a lot of questions. How can it be that in the critical hours of August 14, 19, 20, when we were in this emergency 3 condition, you signal that you pass the test and you still have capacity available? So let's unpack this picture. Next slide, please. Why we passed the test in every single interval on August 14? I think there are two main considerations to discuss. The first one is the construct. Well, let me step back. The first one is really two issues that we had in the calculation. That is what Jeff was pointing out earlier today, right? Could have we cut this earlier if we have a different approach of looking at the gross rather than the incremental? It could or could not. I think the calculation, when you have hundreds of resources, is not very straight to see. And the two miscalculations that we have in the capacity test made a difference. One of the issues that we had was related to the accounting of the mirror resources. These are mathematical artifacts we have in the market application to ensure that we keep the balance for those resources that have some definition in one EIM area and have transactions with another area. The second issue that we had is that for internal resources, debut rates or re-rates were not effectively taken into account in the calculation. So if you have a bill rate for a Pmax of a resource, effectively, you are overestimating the bit range because you are accounting for this extra capacity between the derated value and the Pmax that the test was considering that was still available when in reality it was not. These two issues combined resulted in having effectively a less restrictive test, a more liberal test, and that effectively means that we were passing more intervals than what we should have. And we're going to elaborate on the specific numbers. And the second part is beyond this miscalculation. Once we have corrected for this, we are going to show you that we still have capacity available in these tight hours because of the way we currently have the construct of the bit range. And one of them, naturally, is going to be the lack of consideration for intertemporal constraints. Next slide, please. This has two stories. The first one is if you look at the two bars all together, the cumulative of the two bars, the gray plus the blue, the high tells you the total capacity available that we have for the test as it was indicated in the original solution. Once we have corrected for the two miscalculations in the application, the actual capacity should have been only the portion in gray. That is effectively what was available if the calculation was working properly. That means the portion in blue was the overestimation of the bit range capacity done during the test. And you can see, for instance, our ND19, right? Let's say interval 3. We have original capacity available estimated to be around 2,600 megawatts. In reality, once we have corrected for the issues, it's about 1,000 megawatts of actual available capacity. That is going to make a difference because obviously now with the issues corrected, the capacity is much less than what was originally estimated. Next slide, please. And this is the similar story, but for August 15. And you can see it's actually more extreme in the peak hours because you can see the overestimation was quite significant in comparison to what it should have been. We were estimating to have about 2,000 megawatts of available capacity. In reality, there should have been less than 500, around 250, 300 megawatts, let's say for our ND20 interval 2. Next slide. When we look at into specifically what resources were creating that overestimation of bit range capacity, this gives you the breakdown by technology. And you can see that it's relatively speaking a flat amount in the range of 1,600 megawatts. That is the upper value that you have at the top of all the bars. And that makes sense because this overestimation of bit range capacity was mainly impacted by the lack of consideration of the rates. And the rates do not change from interval to interval. There may be a change from at one point in time, and from there it remains constant. So it makes sense that if we were not accounting for the rates, it was similarly speaking across the board for this period, the same amount, relatively the same amount. And that happens to be the case. And you can see that different technologies were impacted differently to a different extent. The most impacted technology was related to MSG resources. The overestimation of bit range capacity was in the range of 900 megawatts for MSG because of the rates not considered. Next slide. These are just two illustrations of two actual resources that we have in the system. We just masked the resource names, but you can see how it actually worked for August 14. On the top, you have one resource that has a nominal capacity in the range of 420 megawatts. The rate brought down that resource to about 370 megawatts, and that should have been the effective capacity that was made available and accounted for in the test. And the dotted line in red is effectively where the unit was being dispatched in real time. And you can see at some point it reached the Pmax expected. It was around the peak time. So the portion in green is effectively the overestimation of capacity in the bit capacity test. In actual production, the resource was properly dispatched and bounded by the derated value at the 370 megawatts, and you can see that that holds. Very similar story for a second resource. You can see the capacity derated should have been about 400 megawatts. The resource Pmax was just shy of 500 megawatts. The market was dispatching all the time the resource at the derated Pmax that is overlapping in the gray and red lines in the neighborhood of 400 megawatts. That means that the portion in orange that is between 400 and 510 or so is the overestimation of the bit range that was utilized in the capacity test. Again, in actual production, the resource was properly bounded by the derated Pmax. Christine, let's pause. Do we have any questions?
Yes, we do have.
Oh, I'm sorry. Did you have a question in queue?
Yeah, that's okay. Just a reminder, you can press pound 2 to raise your hand. So, Michelle, we'll go to the questions.
All right, very good. Caller, your line is unmuted. You may ask your question. Caller, you may proceed. Your line is unmuted.
Oh, sorry. I think I was on mute. Can you guys hear me?
Yes.
Yes.
Hi, Guillermo. This is Alan Meck from San Diego Gas and Electric. So I just wanted to probe a little bit deeper what your conclusion was about how California continued to pass the resource sufficiency test because of the errors in the bid range calculation and the other tests. So can you say, have you tried rerunning the test and what it would have looked like on August 14th and 15th if those errors were corrected, and how many intervals did we fail on August 14th and 15th, and how many more intervals would we have failed?
Yes, and that's exactly what we wanted to show, and that is what we have in the subsequent slide. So if you can hold a little bit, I think we're going to reach that portion, and yes, we're going to show you exactly what should have been the results in the lack of these issues. Yes, we have all that material
Okay.
for your discussion.
Okay, great. Thank you.
Thanks, Alan.
You're
Any
welcome.
other questions?
There are currently no additional questions in queue.
Okay, next slide. Now, we have the other side of the equation, right? We already covered the bit range. On the requirement side, there was also an impact due to these two miscalculations. And this just shows you the relative comparison of the original calculation and the requirements once we have the correct calculation. And you can see that in general, the issues in the calculation impacted the requirement in such a way that it made the requirement too conservative, too small. Once the issue is corrected, the requirements are actually higher, and in some cases, it's a meaningful amount. This would make two-sided effect. On one end, the miscalculation overestimated the bit range capacity test. It made the left-hand side higher than it should be. On the other end, it also made the requirement lower than it should be. So effectively, it plays in both ways and make the test to pass more easily. And that was the end result as to why we were passing every single interval, even in the critical hours. Next slide, please. Similar to what we do for the supply side, if we want to break down the components of the imbalance requirements to see where the miscalculation had the most impact, you can see that it's only in one place, and that is basically the net interchange. And that makes sense because the effect of the second issue, that was the accounting of the mirrors are some type of intertype transaction, so it makes sense that it's going to be impacting this specific component. So the overall delta that was impacting the requirement really has to do with the net scale interchange. Next slide. Okay, now this is what the last question was about. We know, based on the original solution that we had, that we passed every single interval of the test. We know we have two miscalculations. What if we wouldn't have those issues back on August 14 and 15? How the solution would look like? This is the summary of that question. On the top plot, what you have is the very original outcome of the test. And you can see the requirement was always below the bit range, and we passed on all the intervals of the peak hours. In the plot at the bottom, what you have is the outcome of the test once we have corrected for the issues. Effectively, what we have done is to rerun the test with the right functionality in place. And in this case, you are going to get a much smaller bit range because now we are not over-accounting for the bit rates. And you're going to get also a higher requirement because now we are not accounting for the mirrors. And that two sides combined are going to give us this outcome. And you can see that the dotted line, the requirements is in several instances higher than the bit range, the bars. And that means we're going to fail the test. In conclusion, if we wouldn't have these miscalculations in the capacity test back on August 14 and 15, the picture would have been more like the bottom, where you have 1, 2, 3, 4, 5, 6, 7 intervals around the peak time, the critical time, failing the capacity test. And that better aligns with the reality of what the system was dealing with, that we have very tight supply, we have to set load, we have to arm the load, and so on. This effectively gives you a more realistic view of how the test should have been if everything was working as intended and properly. This is, I would say, a big portion of the story to explain why the CAISO was passing the test back on August 14 and 15. And you can see these are effectively the intervals that we should have failed. And the consequence of failing this capacity test on those intervals is that by default we would have failed the flexible ramp sufficiency test. We would have been bounded by the transfer that we can bring into the CAISO. And I think this picture illustrates very clearly that we were indeed, and the market properly was projecting that we were short of capacity such that we should have failed the test. Next slide. This is the same story, but this is for August 15. And the quantities may be different. The pattern of the outcome is kind of similar, and you can see that at the critical time where we were in the emergency 3 condition, we should have actually failed the test, the capacity test for those intervals. Different to the story that you have at the top where we were passing every single interval for the test. Next slide, please. Now, I think that partially answers the question as to why the CAISO was passing the test or why the CAISO had still capacity available when we were in this tight situation. There may be still a question to be answered here because even if, sorry, Christina, can we get back one slide? Even if we were failing the test, look at, for instance, can you go back one more? Yeah, look at here, for instance, right, our ending 19. Yes, granted, we should have failed the test. I think the still open question is, yeah, you failed the test, but how can it be that the system is telling you that you still have like 1,000 megawatts of capacity in bit range available to move? And at that time, you were basically arming load, dropping load. How can it be that the test is projecting that you still have 1,000 megawatts of capacity, incremental capacity to meet the test? So can we move forward to a slide now, Christina? In order to try to further explain that and answer that question, what we have this, based on the incremental approach, is the breakdown by technology. What resources taking a relative reference point of the FMM stages were considered to have still incremental room to move up in the dispatch. And you can see it's a very interesting profile. The majority of the high of the bars is dominated by the portion in green, and that is MSGs. So let's say, for instance, in one interval in RND 19, right? We're talking about RND 19, interval 3 or 4. We're seeing that we have about 1,000 megawatts of incremental bit range capacity. There are two main components. One is the orange one at the bottom, that is the VR resources, and the rest is effectively the MSG resources. So these two types of technologies were giving us incremental bit range capacity. So let's unpack that to see how that could happen. Next slide, please. This is basically the same for August 15, the same breakdown and different interplays, but at the end of the day, very similar story to be told. Next slide, please. The first component, we see that there was a portion of incremental bit range capacity associated with VRs. And this is the nature of the business. Once you are running a test, as long as that test is looking ahead in the future, you know that there could be two ways to go. You overshoot or you undershoot because the VR is going to be unlikely to match exactly what the forecast is by the time you are running the test. And that is nothing of a surprise. We know that VRs move quite dynamically. And I believe in one of the updates that we provided to the MSC back in October, specifically I covered the material of how the VRs move very rapidly for August 14 and 15. Wind specifically was moving very, very largely. And what you have here is the different profiles of the wind and solar all together for the critical hours of August 14. The portion in orange at the top is the estimated incremental bit range capacity that the test believes we have available from VR resources. And you have, as a reference, the other trends. What was the FMM dispatch and the actual production. And you can see that by the time we run into the actual production, the line in purple, that was quite a lot of capacity that didn't show up because we were producing less than what was forecasted in the 15-minute market. This is the reality of the business. We are dealing with VR resources. We know that there's an inherent component of uncertainty. And indeed, that is the reason we have this uncertainty component built up in the flexible RAM sufficiency test. The second component is the MSGs. And I think out of these almost 800 megawatts or 900 megawatts of incremental bit range capacity available for that specific time, the majority accrue on two specific MSG units. Again, we are just masking the units, but there may be a bit intuitive to know which ones those are. This one specifically for August 14 shows the profile across the critical hours. This is a resource that was trying to come back online in real time, and you can see that through the line in purple. That is the production, the actual output that we are getting from that unit. And you can see that it was trying to come back, but it could never really made it onto the system. By the time we were running the test, that resource have effectively a Pmax of 770 megawatts or so. The bit was there. The resource was trying to come online. It couldn't, but for the purpose, for the sake of the test, that is what matters. The resource at a bit was there in the market. Whether it could come online or not, that was more of the operational condition. This is one of the factors that play a role in the current structure of the capacity test, and that is we do not account for intertemporal constraints. The bit is there, good for 700 plus megawatts. Whether the resource can come online or not and get access to that capacity, that is the implication of the intertemporal constraints. So effectively, the test was considering that we did have this 770 megawatts of bit range capacity available because the bit was there, the resource was not on outage, and therefore it considered that it could get that bit range capacity available. Let me cover one more slide and then we can pause for questions. The second resource is interesting, I would say, because you could say that based on a relative reference of where the most recent FMM schedule was projecting that resource to be, we were considering that that resource could really have up to 400 plus megawatts of capacity available. And indeed, when you compare that against the purple line, that is the actual production, you can see that we indeed utilize fully that capacity up to its Pmax. And indeed, when you look at the profile going for our engine 19 and 20, the resource actually was delivering above what was currently represented by the bit. It has a bit of, 440, 30 megawatts. The resource was giving above 450 megawatts. So this resource indeed had the capacity, and the market indeed utilized fully that capacity, even the extra megawatts that were available for the night hours. Okay, Michelle, let's see if we have any questions.
Sure. I know we have one person in the queue, but again, just press #2 to raise your hand if you have a question.
All right, caller, your line is unmuted. You may go ahead.
Hey, Guillermo, Dan Williams from Customized Energy Solutions again. Two questions actually, but one going back to, I think maybe slide 19 is the best one to highlight on.
Can we go back to that?
Yeah, either 19 or 20. So I think maybe the other one highlighted it better, but between interval 4 and interval 1, where you see the steep down ramp in the imbalance requirement, is that generally driven by ramping across the top of the hour during a period when you're bringing in additional supply, or what's kind of the general driver for that kind of pattern of the steep drop-off in the imbalance requirement moving between hours?
I wouldn't like to generalize, Dan, because this thing is very dynamic. But what I can tell you, generally speaking, is what makes the requirement, right? And that is the load forecast, the net schedule interchange, and that's it. So if you could see that there is a sudden change between hours, naturally you may think that the net schedule interchange is adjusting, right? And if you are in certain times of the ramp, that may be one of the factors that play a role, because now your requirement is going to be higher or lower depending on what direction of the ramp you are. So, and there are really no many other components in there to drive the difference. It's either the load forecast changing or the net schedule interchange moving around. And it could make sense also that it may happen between hours only and not intra-hour, because the net schedule interchange is going to be effectively on an hourly basis.
Right. Okay. I appreciate that. And then on slide 23, I think it was, the one on the VERS slide, if I got my numbers correct. Maybe one more forward. Yeah, that one. Looking forward, the CAISO's developing this quantile regression methodology, I think, to better or more accurately capture the uncertainty related to VERS and load and other things in the future. Do you think that would have created or would have picked up this steep underproduction by the VERS, or do you think in the future we'll still kind of have to be in that place where the operators have to be looking at the system and kind of seeing what potential loss of generation is there, and having to do bias or do some other type of an activity to make sure that they've prepared the system for that potential loss? So sort of, is it an issue that's going to get fixed a bit with the new methodology, or is it something that will still kind of be there just by nature of the system? Yeah,
I think your question then has more than one dimension. I think one dimension is naturally what happens in the actual real-time market, in which we have to handle the uncertainty, right? If the current calculation that we have for the requirements is not good enough, that may put us in a condition where we have these misses, or the operators have to take active action to manage that uncertainty materializing. So I think one dimension is really what happens in the market. And yes, the quantile regression that we have been working for many months to bring it to production should help us to get a more efficient estimation of the requirements, because it's not going to be based just on the last historical days, but it's going to take into account also current production where you are and current forecast where you are. So that on its own is going to bring benefits to be more accurate. Now, the other dimension is more on the context of the test. For the flexible ramp sufficiency test, yes, that is going to have a straight impact, because the flexible ramp sufficiency test relies on that component of the uncertainty, right? We have the net movement and the uncertainty component that make up the requirement for the test. So having a more accurate component of the uncertainty is going to go a long way for the flexible ramp sufficiency test. However, when we're talking about the capacity test, I don't think that is quite straight, because if you look at, again, the components that make up the capacity test, what you have is your bit range that is somehow unrelated to what the uncertainty is going to be. You just have the bits. And the other side of the equation, that is the load forecast and the net schedule interchange. So there is no natural component that captures the uncertainty, whether that uncertainty is good or not so good. At the very end of the presentation, I think I put one slide to highlight what would have been the outcome if we are going to move into the enhancement that we're going to use for the test moving forward, and that is to effectively bring in the uncertainty component. So if now we're going to include the uncertainty component, yes, in the future, once that uncertainty component is based on the quantile regression, it's going to be more precise and is going to measure more properly, even in the test space, the right amount of variation that we have. So in the longer term, once we have the enhancement, it should make a difference. Prior to having this enhancement on the test, whether we have the quantile regression or the historical histogram uncertainty calculation, wouldn't make a difference.
Got it. I appreciate that explanation. It helps fill in some of the kind of expectations when thinking about how this might perform in the future. So thanks for that.
You're welcome.
I think we have others in the queue. Is that correct, Michelle?
Yes, we are moving to the next question in the queue. Caller, your line is unmuted. You may ask your question.
Hi, this is Todd Ryan from Pacific Gas and Electric. Can you hear me?
Yes, we can hear you.
Hi, thank you. I'm curious if my memory serves, there was the PIME software that was creating export schedules that were maybe wouldn't be supported by internal generation, and it shouldn't have been scheduled, and therefore might have affected our the total requirement to meet this test. Did you account for that in any kind of way, or could you account for that, or can you qualitatively talk through what that effect might have been had that issue, the software not been enabled on these days?
Yeah, I think I generally know what your question is about, but I would like to, there are different variations of what you may be referring to regarding the exports. Can you please expand a little bit more to make sure I understand specifically what variation you are talking about?
Of course. My understanding is that the PIME software was resulting in exports that weren't supported by internal generation and shouldn't have been scheduled. And to me, that means that it effectively made CAISO's BAA's load appear higher and therefore would have affected the capacity test. It would have raised the bar ever so slightly or largely. I don't know the full effect. And so the question is, does this analysis take into account that effect? If not, does your understanding match my understanding that maybe this analysis might overestimate the failure given those maybe erroneous exports?
Okay, yeah, thank you for the reference. Now I can really answer that. Yes, let me give just a short background on this to have everybody on the same page. What you are referring is to the discussion we have about the export treatment and the explicit change that we implemented on September 5th to align better the practice of how the exports are considered, not just in the ROC process, but also in the real-time market. To first answer your question, I think, yes, there will be an impact, but I will have to caveat that later, in the way we are doing the test, because effectively accounting for more or less exports is straightforward going to impact the amount of net scale interchange that you're going to subtract to make up the total requirements. So you have more exports, that is going to reduce your net scale interchange, and you're going to subtract a smaller amount to the requirements, and therefore you have to meet a higher requirement for the test. And the other way around, right? Now, that would be just to answer straightforward your question. Now, I need to caveat this because I think there are many different moving pieces on the logic that you explained. The tiny issue in the ROC process on its own wouldn't create the problem completely. It is that, together with the fact that as of September 5th, we have the practice that any self-schedule coming from day ahead into the real time, if they were self-scheduled, they were protected with a high priority assignment up to the IFM solution. And that is really the genesis of the whole discussion that we have in the readiness, in the summer readiness enhancement. It's not just ROC alone that would have created this problem. It has to be in combination with the fact that once you clear something in the day-ahead market, a participant with an export can self-schedule that award up to the IFM schedule. Effectively, what we did on September 5th is to have two changes. First, we turned the PIME functionality off to ensure that we can better assess the amount of curtailments for export that we have. But together with that, in order to effectuate a material change, we also adjusted the logic in the real-time market in which the self-schedules coming with this day-ahead priority have to be up to the ROC schedule. Prior to September 5th, it was up to IFM schedule. If your reference in the real time is up to IFM schedule, whatever happens in ROC is kind of a moot point because you can still set the scale up to the IFM schedule. So I need to give this context to try to put the bigger picture here. Does that answer your question?
That's helpful. But just to be clear, this analysis doesn't try to account for that policy change on the September 5th.
No, because what we go is with whatever the solution was for the real time, right? And the solution in that sense was the right solution based on the business practice that we have at that time. I guess your question may be...
Understood.
If we're going to leave it, Well,
sorry, I didn't mean to interrupt the lag.
No, sorry.
Difficulties.
Yeah.
My point being that if we're using these data to inform future policy discussions, it might also be helpful to understand, given not just what the policies were on those dates, but how would the current policies or changes to future policies have affected these days. So thank you. Appreciate your help.
You're welcome. Michelle, Christina? Any other questions?
Go ahead. Yep, we have a few more questions in queue.
Okay.
Caller, your line is unmuted. You may ask your question.
Hey, Guillermo, it's Mark Smith with Calpine. Here it looks like hi, it's good to hear you, Guillermo. Slide 25, I think we're already on. I'm a little confused as to how you're referencing this as an intertemporal constraint problem. This looks very curious to me. I don't understand why FMM would continuously dispatch this resource, presumably under a lower configuration, when its operation was continuously above that. That seems like an operational issue, not an intertemporal issue. I can see how the overestimation occurred. I get that. You know, the blue area is presumed to be bid dispatch range, but the unit's already running up there, so it's overstating the bid dispatch range. But how could FMM continuously under forecast actual production?
Yes, just to be clear, Mark, the intertemporal point was not on this resource, it was on the previous one.
Okay. Okay. I thought. Okay.
No,
this is just another error within MSG resource that indicates why the bid range was overstated.
Can we go back one slide, please? I want to make a point here.
I'm having a screen's frozen here. Michelle, can you go back a slide? Are you able to control it?
Yep, just one moment.
Thank you. My screen is frozen.
But let me try to answer this way, Mark. I'm illustrating with two MSG units how we accounted for 1,000 megawatts of MSG bit range capacity available. The first unit that was in the range of 770 megawatts was giving us that bit range because the market assumed that we did have that bit range. The bit was there, the resource was available, and whether it was coming online or not because of the temporal constraints and the challenges to really start the unit, that played in a different way in the real time. But for the test purpose, yes. The fact that we don't have any intertemporal constraints, we could assume that we have access to all these 770 megawatts. That was the intertemporal constraint discussion. The second issue, I think I would characterize that the second resource has no issues. All what you are getting here is a relative comparison of what the incremental bit range may tell you that makes up this 1,000 megawatts. But at the end of the day, the resource have a bit of 400 plus megawatts, and you could see that the market actually utilized the full bit range. I wouldn't characterize the second resource to be an issue. It's just highlighting that, yeah, for the incremental assessment, we are estimating that that resource indeed had bit range and indeed was utilized properly in the market. So no issues for the second one.
But why did the FMM keep it locked in the lower configuration? That's what I don't understand.
Yeah, and this is something that I would have to go back and check. This is what we found. And keep in mind, this is an advisory projection in FMM. It's not even the actual FMM schedule. It's just your projection by the time of the test.
Okay, gotcha. Thank you, because you're doing this well in advance of real time. Okay. Thanks, Guillermo. I understand now.
You're welcome, Mark. Do we have any other questions?
I think we have two more in the queue. Is that correct, Michelle?
Yes, we do.
Okay.
I will go ahead and unmute them. Caller, your line is unmuted. You may ask your question.
Good morning. It's Mark Simons at Quantile again. Actually, that slide that you were just on was actually very fortunate. Guillermo,
which one?
This slide, there's no numbers here, so it makes it a little more difficult, but this was the D-rate discussion. Has the dotted line for dispatch capacity here, whereas the ones that we were just talking about have both the dispatch line and the actual production. What does this dotted line represent? Is this FMM dispatch?
No, this is actually RTD dispatch.
RTD dispatch? And are we able to see the actual production for these units?
Oh, yeah. And in some cases, we show actual production in some other cases, and I think that is in one of the subsequent slides. Yes, we did have all that.
Okay, that'll be a good addition for this slide. Thank you.
Yeah. Okay. Okay, it's 11:45, and I think we still have some material. So let me do this. Let me just walk through the end of the deck, and then if we still have time for questions, we can take it as much as we can afford. But I would really like to cover the whole material. Okay, this is the next. Can you go back one slide? I just want to make sure this is the next one. Okay, yes. The next one. This has to do. If you go back to the slide where we have the available bit range capacity with the different breakdowns, there is a portion that has a component of imports and exports. And the whole point I want to make here is that in some cases, the imports and exports can make bit range capacity available. Can we move one slide, please? And for exports, it's quite interesting to see how the logic works, because first, it has to be 15-minute export. If it is an hourly export, that is considered as fixed, as given in the site of the requirements, and we have discussed that. In these cases, you can see that it's a little bit scattered, and the nature has to do with how we account for the bit range for exports. If there is a 15-minute export, effectively we are assuming that that resource can be economically dispatched in the binding FMM interval. So if we are projecting that this export is going to be awarded, let's say 250 megawatts for the first 3 intervals of 2017, effectively, when it comes to the FMM binding run, if we need capacity, we can bring down that export to effectively 0 megawatts. And by reducing that projected award of 250 to 0, we gain bit range in that amount of 250 megawatts. You can see here the interesting part in our engine 19, for instance, when it was the critical hour. The export was projected to be awarded 0. We didn't have much capacity to be awarding economical 15-minute exports. And therefore, there was no bit range capacity that these exports could give us because they were already at 0. And this is the right way to account for the export capacity, but only for 15-minute resources. Next slide is the same story, but for imports. We happen to have, for our engine 18, one import that show up on 15-minute basis, and you can see the dotted line at the top at the same level of the estimated bit range. The bit range was estimating that we could utilize these 15-minute resources, and when it came to actual production, the resource indeed was clear at 200 megawatts. So it was capacity that showed up in the bit range, and we eventually utilized in the real-time market. Next slide, please. Another component that we have to consider is the forecast, right? We are talking about the forecast that is utilized for the test. Eventually, that forecast may be slightly different to the one used for running the binding interval, the ones that actually comes into the real-time market in 5-minute basis, and the actual production. So this just gives you a snapshot of the variations of the requirements across the different time frames. One for the test, the others for the RTPD and RTD markets. Next slide. Now, there was a question at the beginning of the call, and I believe it was from Dan, regarding the operator's actions and how that may influence one way or the other the capacity that is effectively made available to the system. And yes, on August 14, taking it as a reference, there were different actions taken by the operators to try to regain capacity. On one end, we dispatch manually reliability demand response resources in the range of 970, 980 megawatts. And you can see the profile of those dispatches on the right-hand side plot. We also arm the load. First 500 megawatts, then we arm an extra 500 for a total of 1,000 megawatts. Dynamically, the operators also try to bring additional interties into the system. So, and these were just 3 different actions that effectively resulted in additional capacity that naturally was not considered in the capacity test because of the timing of the action or because of the nature of the action. And let me go one more slide, Christina. This is just a very graphical illustration of the actions that took place on August 14. In purple, you have the time span where we have the emergency 2. The one in red is the portion for the emergency 3. During the emergency 3, we shed 500 megawatts of load at the beginning at 6:38 p.m. and 500 more at 6:53 p.m. The E3 ended around 8:38 p.m. Now, on the lower side, on green, you have different actions that the operators took. First, load was armed. What does that mean? That effectively, we were saying that we could drop load within the reliability time frame, and in lieu of that, we could effectively release operating reserves that could be converted into energy to meet our demand condition. So we were arming the load. First, in the range of 500 megawatts, and then at 6:32 p.m., just prior to shedding load for the first time, we increased that up to 1,000 megawatts in total. Within the same time frame, we dispatch a reliability demand response. Depending on the amount, you can see that it could be close to 1,000 megawatts. Next slide, please. The point of bringing these items is that by the time we were running the test and assessing the test, we have certain information about the capacity that was available, and that is naturally reflected by the bits that we have available. By the time we actually run into the actual operation of the system, the operators were taking actions to gain more capacity, as we just described. It's an exercise, and I want you to look this as it is, as an exercise to assess how this balance out. If we have additional capacity that was gained in the actual operation of the system, granted, the test is already behind us, it already was done 40 minutes earlier, but in a holistic view of counting the megawatts by the actual time, how this could have played overall in terms of the balancing of the system. Next slide, please. This is, again, an exercise to try to get a rough idea what it really means. The portion in green is the original and corrected capacity that we get from the bit range test when we have corrected for the miscalculation. And we are just piling up 2 types of capacity that we gain in the real time. One, by having manual dispatches on interties, we gain certain energy, additional energy, and also we gain some energy by converting the operating reserves by arming the load. The load was still armed. We could drop it if needed to meet our operating reserves, but that conversion of a spinning or a non-spinning to energy effectively meant that we have additional capacity to meet our energy needs. So if you put all this put together with the original capacity test information that we have, and on top of that, we adjust the requirements. Instead of using the FMM load forecast, what we actually use is the actual load. That actual load is going to account not just for the actual load that realized, but the effects of having dispatched reliability demand response. If we dispatch 900, we may have gotten 700 megawatts of that in response, and also of the dropping the load. When we drop the load 500 megawatts, the actuals effectively are going to show that capacity. So this dotted line reflects the actual load that internalizes dispatches of demand response, dropping the load. And on the supply side, we have the additional capacity of arming the load and also manual dispatches. In that case, if you try to do the exercise of assessing supply versus requirements, you can see that the failures could have resulted more surgically at the critical time of the beginning, at the end of our ending 19. And that is where the requirements are higher than the capacity, overall capacity that we may have available. There may be other intervals here and there that have the same condition, like our ending 19 interval 2. And again, this is simply an exercise that acknowledging that there were actions taken by operators in the real time to regain capacity. How, in a hindsight perspective, that would make the balance of the overall capacity in the context of the capacity test to play out. And this is just food for thought. Next slide, please. This one, just to give you a preamble. So we have the outcome of the test, pass or fail. And subsequently, when we run the real-time market, either the 15-minute market or the 5-minute market, in some cases, we may run into infeasibilities. It means we don't have enough supply to meet our total requirement. That is somehow, in principle, similar to the test, right? At the end of the day, it's kind of doing the same test. This one overlaps the intervals in which we have FMM and RTD infeasibilities together with the intervals in which we would have capacity test failures, once we have corrected for the issues that we discussed originally. Christina, I don't recall if we have one more. Yes, okay. I believe this is the last one. This one is taking as a reference the correct outcome of the test once we have fixed the issues, and then we add the uncertainty requirement. And that is, I believe, the proposal that we have from the summer readiness. That would effectively increase the overall requirements for the capacity test. If we were doing that back on August 14 with no issues in the calculation, how different the pass or fail would have been for the test. In this scenario, you can see that the requirement is going to increase naturally because we have an incremental requirement, and that is going to result effectively in 2 more intervals to fail. So this is just to give you a brief assessment of how the enhancement would play out if that were in place back in August. I believe that's all the material that we have. So I think we have a few minutes so that we can entertain any remaining questions that we may have. Michelle?
Absolutely. We do have questions in queue. Caller, your line is unmuted. You may ask your question.
Hi, Guillermo. It's Jeff Spires again from PowerX. Thanks for going through all of this. There's a lot of great information here. It's a lot to digest as well. I think it might be worth considering another call potentially to go through some of the back half of this slide deck in a bit more detail, just because there's so many pretty complicated topics that you ran through pretty quick there. One of the questions I have, or first of all, I think, you know, the slide you have here about including uncertainty in the calculation it makes sense as far as saying when we're evaluating the amount of resources that need to be available in the upcoming hour, we have to recognize some amount of uncertainty in the forecasts. It looks like the uncertainty for the CAISO-BA in these intervals was about 1,000 megawatts, but looking at the previous slides that I just want to make sure I'm understanding, it looks like the error between the forecasts of load and of VARs that was used in the capacity test looks like the error from that to either the FMM or the real-time was quite a bit larger than that. It looks like it could be around 2,500 megawatts of forecast error, and I just wanted to confirm if you agree with that. And just, I guess my question is, does that sound right to you? And maybe there is something to explore there further in terms of what load or what VAR forecast is going into the test. Is it old or something that maybe is not reflecting what the market operators are using in the market? Because it just seems like that's a pretty big delta, and I just wanted to get your thoughts on what you think might be driving that.
Yeah, thank you, Jeff. Yeah, first of all, I think this shouldn't be seen as the end of the discussion. I would see this actually as the starting point of the discussion for the upcoming initiative we are going to be launching for the resource sufficiency evaluation. So I think there will be naturally a lot of opportunity to go into the details of the implications and what we may be thinking for changes or improvements or enhancements. So yes, there will be more opportunities for that. The second portion, I think you are right on point, because the capacity test is simply using the load forecast. The comparison I put in the previous slide is actually the final requirement that the market is using to balance, and that is going to include effectively the load conformance that we have in the real-time market.
Okay. Thanks for that. I'll let others, I know we're running out of time, but thanks for that. I appreciate it.
Thank you, Jeff.
Michelle, how many do we have in the queue? We're out of time. So
we currently have 2 additional callers in queue.
Okay, so we'll go ahead and take the queue before we conclude. So thank you.
All right, very good. Caller, your line is unmuted. You may ask your question. Caller, you may proceed. Your line is unmuted. Caller, you may have your device or phone on mute.
Question.
Can we move to the next one?
Yes, we're going to move to the next question. Caller, your line is unmuted. You may ask your question.
Guillermo, good afternoon now. It's Mark Simons at Bonneville. I just wanted to clarify on this last slide, is this just the uncertainty requirement, or is it net of the diversity credit? And
specific method,
what is the policy? And what is the policy that's being implemented?
Yeah, I can tell you what I added, and I will let somebody from policy to explain on the specifics of the enhancement. What I added is simply the uncertainty component as is, no diversity adjustment or anything, just the gross uncertainty requirement. Brad, Danny, do you want to expand on what specifically we are considering the enhancement?
This is Danny. The enhancement was just to add the uncertainty native to each BAA area.
Got it. Thank you both.
Okay.
Okay, great. Thank you.
Okay. Can we go back now to the slide number 2, please? Just 10 seconds.
You want slide 2?
2 or 3. Let's see. That one. This one. Okay. Yes. I want to wrap up this call, coming back to the origin of the reason for this call. And obviously, we take very seriously the fact that some participants expressed their concerns about the CAISO still not meeting the expectations about discussing what really happened with the capacity test for the CAISO and how that worked out and what issues we had and whether the transfers were included. I just want to summarize this and come back to this slide because the intent of having all this discussion and providing all the transparency and all the information that you have seen, at the end of the day, is to be able to answer very shortly the questions that were still open and pending for participants to get comfortable. And in summary, first, we do not include EIM transfers in the calculation of the test, not for the CAISO, not for EIM entities. And how could it be that the CAISO passed the test under these tight conditions? And you know that there were at least two reasons. One of those was partially due to the calculation errors that we have in the test that were fixed on February. And you know that after accounting for those, we would have indeed failed the test in several instances. And we also have the current structure accounts for capacity that may be limited by intertemporal constraints, and we are not doing that consideration of the intertemporal constraints. And the last piece obviously has to do with the fact that we, at best, are doing a test as a projection for the actual conditions. Between the time we run the test to the time we actually deal with the condition, things are going to change. And you can see that VR resources produces slightly different to what was considered in the test and so on. With that, I hope that we have been able to address fully the open questions that were still lingering about this topic. And as I indicated, I wouldn't see this as the end of the discussion about the resource sufficiency evaluation. I indeed see this the other way around. That is going to be the starting point for the upcoming policy initiative about the resource sufficiency evaluation. Thank you for your time. I know it's a lot of material, but if you have any questions, please just let us know and see if we are still okay with the scope of this material or whether there are still questions lingering there to be answered. Thank you for your time.
Hey, Guillermo, this is Danny. I wanted to clarify that answer I gave to Mark real quick. It would be the uncertainty less the diversity benefit. So I just wanted to make sure we're clear on that.
Okay, thank you, Danny.
Okay, great. Thank you, everyone. Appreciate your participation. A lot of good questions today. So, again, the presentation that Guillermo went through today is on the Market Enhancement for Summer 2021 Readiness Initiative webpage. You can also access it through the public calendar. So thank you all again, and enjoy the rest of your day. Thank you, Michelle.
That concludes our conference. Thank you for using Event Services. You may now disconnect.